Oh, here we go. Okay. So this axis right here, the vertical one, is called the y-axis. And this axis right here is called the x-axis, right? Now, whenever you want to plot any point, it's going to be in this order. You're going to have a pair of parentheses with a comma in the middle. Yes? Now, over here, you're going to insert the x value, and over here, you're going to insert the y value. So whenever you see a pair with a comma in the middle and two values here, these are the coordinates for a specific point. So let's try plotting these, and so you guys would understand the concept more. For example, A, which is 2, 3, right? So I'm basically telling you that on the x-axis, it's a 2, and on the y-axis, it's a 3. So on the x-axis, which is a horizontal one, look for 2. So that's 0, 1, 2, right here. Yeah? Now, on the y-axis, look for 3. 1, 2, 3, which is right here, right? Now, just extend from each point until the two meet, right? So I want you to think of like one straight line going from both, and the point of its intersection is the point you need. So this one right here, that's A. Make sense? So this is the point 2, 3, where on the x-axis, like moving horizontally, it's a 2, and moving vertically, it's a 3. So the point is right here. Okay? Let's try another one. We have -4 and 6. Okay? -4 on the x is right here. Yeah? And on the y, I'm giving you +6, which is right here. So we go all the way to +6 along the line of -4. That's B. Yeah? Next one is 0 and 2.5. Okay, so for x, it's 0, which is right here. Going up to 2, that's 3, so 2.5 would be right here. That's C. Okay. What about D? We have -3/4. So go to the negative on x. It's just before 1. 1 will be right about here. Just before 1, since it's 3/4, right? Maybe here, like that. Yeah? That's the x value. And since y is 0, this is actually my point. That's D. Okay. What about E? Now, root of 2 is about what? 1.14, right? So, what do you have? Square root of 2 minus 2. So on the y, it's a -2. On the x, it's a little less than 2. So should be right around here. Okay, that's E. Now you don't have to know the value of the square root of 2 off the top of your head. You could just look it up. Yeah. Right. What about F? Pi is what? 3.14, right? So you go to the positive, and you go 1, 2, 3, little after 3, so maybe right around here. And then I need -4 on the y, which is here. So the point is right there. That's F. Does anybody have any question about this? So plotting points, all you have to do is move in a straight line from each. Okay, quick question. Why is A plotted as 4, 3? You're right. I did plot it as 4, 3. Thank you for spotting that. Because I was counting 1, 2, and I counted it incorrectly. Because the axis, as you can see, is 2, 4, 6, even numbers. So starting off, I just did it as this point being 2 before I noticed. So yeah, you are absolutely correct. So if it's at 2, it would be right here. This is A, not that one. Yeah? Thank you for noticing that. Everybody, please correct your notes. Okay? All right. Now, next up is the distance formula, which you can see right here. So for the distance formula, I'm basically asking you to give me the measurement in distance between 2 points, right? So if I, for example, ask you to give me a distance between E and F, this is what you're going to use. Make sense? I need to know what this space is. What's the measurement for that? Okay? So how do we do it? The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what's y2, y1, x2, x1? Let's look at this example. I have 2 points, and I'm asking you to give me a distance between these two. So looking at it, you can mix and match, it doesn't matter. But make sure that whichever you choose as your 1 stays your 1. For example, this pair right here, if I say this is my first point, this is point number 1, and this is point number 2, that means this is my x1, y1, x2, y2. If you want to make this your 1 and that's your 2, that's fine. Then this would be x2, y2, x1, y1. But I don't ever want to see you give me x1, y2, for example, and then x2, y1. Don't do that. Whichever point has the number 1, each value is going to be 1. This one, 2 for both. Okay? Once you designate which is which, you can solve. Now again, it doesn't matter which one you choose to be your 1, which one you choose to be your 2. Even if you chose to flip, that's fine. Why? Because in the distance formula, it's true that I'm asking you to give me a subtraction, but after you do that, whatever the difference is, it's just going to vary between negative and a positive number. So if you subtract, for example, -3 from +3, that's going to give you what? A -6. But if you flip it and subtract -3 from 3, then it's going to be 3 minus -3, which is +6. But in both cases, the answer is 6, positive or negative. And squaring a number would automatically mean you don't care about the sign, because squaring -6 or squaring +6 would give you the same answer. Does that make sense? Which is why it doesn't matter which one you choose. It will always be the same result if you calculate it correctly. Okay? So just pick a point, say this is point 1, this is point 2, and then plug them in here. Here we go. D equals square root of. Now, we're starting with x2, right? So this value, which is 3, minus x1, which is right here, -3 squared, plus. Now I want y2, which is 0, minus -4, which is my y1. What was it? Squared. Yeah? Okay. This equals what? Negative and negative over here are going to turn positive, because subtraction of a negative is a positive number. You flip the signs. Is everybody familiar with this rule? I want to move on if I confused you. Everybody with me? Yeah? Okay, good. So, since now they're both positive, why do you flip the sign? Okay, there we go. So, when you're, no problem. When you're subtracting, let me grab a blank piece of paper so I don't run out of space here. Okay, very quick. Now, when you have a positive number minus a negative number, right? I'm basically asking you to subtract a -3, right? So if I have a +3 and I ask you to subtract a 3, the answer in this case would be 0, right? But if you're subtracting a negative number, the answer is going to be 6, right? So Well, I was supposed to write it here. But anyway, so the answer is supposed to be 6. But because students see this and confuse it to be 0, what you need to do is whenever you see a subtraction sign, make it positive. But when you do that, you flip the sign that comes afterwards. So now they're both positive. And 3 plus 3 is 6. Now, if it was the other way around, so you have -4 minus 2, for example, right? Flip this, flip that. So the flip works with any case you see, okay? So -4 plus -2 is what? -6. What if I give you -5 plus 2? There's no flipping here. You don't flip the first one. That's a sign. You just add this. And this is -3. What if I give you 2 minus 3? You can flip this. You don't have to. It's easy to just solve. But you can. And if you do, flip, flip. So 2 plus -3 is -1. Does that make sense? So whenever you have subtraction, you can technically turn it into a positive, into addition. But once you do that, you have to flip the sign of the number that comes afterwards. And the same rule kind of applies to equations. Like if you remember when we talked about quadratics, we had 2x squared plus bx plus c equals 0, right? This is the standard quadratic form. So when we used to say in the quadratic formula that b has to be -b in the equation, right? So if I gave you x squared minus 7x plus c equals 0. What's my b in this case? We don't say 7. We say what? -7, right? We take the operation too, because what you're taking in this case is actually the sign. This equation right here can be rewritten as follows: plus -7x, which is why this is -7. Does that make sense? Yeah? Okay. Now back to, oops, this. All right, now. So we have 3 plus 3, which is 6. We're going to do the same trick over here. 0 plus 4 is 4. Now, 6 squared is what? 36, right? Okay. 4 squared is what? It's 16. So now I have the root of the addition between 36 and 16, which is 54 under the root. Nope, 52, sorry. It's 52 under the root. Right? So square root of 52. That's the distance. If you want to simplify, you can. This equals, take a 2 out. 52 is 13 times 4. So it's going to be square root of 4 times square root of 32, which is essentially 2 times 13 under the root. But I don't really care about the step. It's fine. But make sure you give me the approximation, because I think the homework is going to ask for that. So if you plug this into the calculator, what does it give you? It should be about 7.21-ish. Yeah? Okay, let's try another one. So this one. Here you go. Distance of. Now, you pick. Do you want this one to be 0.1 or 0.2? Come on, guys. 1 or 2? One. Okay, so this is 1. That's 2. Okay, we chose. Now, that means this is x1, y1, x2, y2. Here we go. So x2 is 3.8 minus 1.2, and it's negative. Okay? Square. Plus, open up the other one. Y2 is 1.5 minus y1, which is 4.5 squared. Okay? Equals. Now, subtraction here can be flipped, right? Both turn positive. That looks like a straight line now. There we go. Both turn positive, and I'm adding. So 3.8 plus 1.2 is what? The 0.2 and 0.8 give you 1, so that's 4. With the 1, that's 5. So it's 5 squared. 5 squared is 25. So I'm writing 25. Plus, over here, 1.5 minus 4.5 is going to be negative 3. Negative 3 squared is going to be 9. So this equals what? The addition between 25 and 9 is 34 under the root, and which is approximately 5.83. And I already have this calculated. I remember one time a student asked me, how do you calculate a root in your head? It's like, I don't. I can't do that. But yeah. So, any questions so far? So far, so good? All right, good. Let's move on. I'm going to skip this one. Feel free to try it. Actually, since exam 1 is approaching, and I think I saw someone ask about exam 1 before the class started. Your exam is on September 24th. All right, that is next Thursday, not this week, next week. And on that Thursday, the exam is going to cover all of chapter 1, all of it. Everything we covered up until today. This does not include. All right, everything we went over is going to be in your exam 1. Okay. All right. Oops. Now to the next fun part. Let's look at this application right here. The question says, determine the given point from the vertices. And I want to see if they form a right angle, right? So 4 is no, it's not extra credit. No, it's too easy for extra credit. If I'm going to give you extra credit, it's going to be a challenge. Anyway, so I want to look at these 3 points. And the question says, do they form a right angle triangle? Yes or no? Okay. First, let's plot them. A is -2 and +1. So -2 on the x-axis, which is right here, and +1 right here. That's A. Okay. B is 2 and 5. So I need 2 on the x and 5 on the y. 1, 2, 3, 4, 5 right here. That point. This is B. C is 5 and 2, the opposite. So you go 1, 2, 3, 4, 5, 1, 2. No, so 1, 2, up, not down. It's +2. Okay, that's your C. So I'm going to connect the dots. And I apparently can't draw straight lines. Just go. These are supposed to be straight lines. All right, so here's my triangle. Now, is it the right angle triangle? Yes or no? Now, it could be. This could be a right angle, but we're not sure, right? You don't know if this is 90 degrees or if it's 89 or 91. It could look like it, but you're not certain. So how do we know for sure? We're going to calculate the distances, right? Because one way of finding out if the angles, if a triangle is a right angle triangle is what? Using Pythagoras theorem. That's how we usually find the length of one of the sides, by using Pythagoras to and calculate the other two, right? So what if I calculated all of them and then make sure they actually equal each other? So let's see. A, B, and C. if I want to find the distance between point A and B, so this side right here, I'm going to find the distance of A, comma, B. Okay? Which is what? Square root of. Now, according to this order, this is number 1, and that's number 2. You can flip, that's fine. But make sure you're using A and B. All right? So let's start. You have -2 and 1, and you have 2 and 5. This is my x1, y1, x2, y2. Okay. So 2 goes here, minus -2 squared, plus 5 minus 1 squared. Okay. This equals what? This turns positive, so does that. So you get 4 squared plus 4 squared. So they're both 4. So you get 16 and 16, right? That is the root of 32. So this is A and B. Let's do the next distance. This one, I'm going to do B and C. Okay? Now, for B and C, I'm using these 2 points. Since I have to B marked as 2, I'll just make this 1, for example. You can mix and match, it's fine. So, oh, sorry, it's 1. X1, Y1. Okay. So, X2, which is 2, minus X1, which is 5 squared, plus Y2, which is 5, minus Y1, which is 2 squared. Notice the numbers are the same. You have 2 minus 5 and 5 minus 2. In both cases, it's going to give you 3, negative and positive. When you square 3, whether negative or positive, it gives you 9. So both answers are 9. 9 plus 9 is 18. So we got this one, we got that one. Now let's do A and C. Distance, A and C. Okay. Now, I need to choose which one's going to be my A1, first point, and which one's going to be my second point. Again, it doesn't matter which one you choose. So I'm keeping A as 1, and I'm making C number 2. Okay? So we're starting with the values of C. You have 5 minus -2 squared plus 2 minus 1 squared. So these get added and these subtracted. So we have what? 7 squared plus 1 squared. So that's 49 plus 1, which is 50. Root of 50. So far so good? You guys are too quiet. You with me? Okay, good. Now we're going to use Pythagoras theorem, which is a squared plus b squared equals what? C squared, right? That's the idea. So this is my C. That's A and that's B. Okay. So that means I take these two and I'm going to square them. So a root squared, what happens to it? What happens to it? The root cancels with the square, right? Yeah, exactly. So you only end up with a number. So that's what we're getting. So you're going to get 18 plus 32. And it equals 50. So adding these together, does that give you 50? Yes, it does. Therefore, the answer is yes. This is the right angle triangle. I like this problem. Not equal A, I'm saying that this side is side A. You can switch if you want, but it's the same idea. Make sense? You can name these M, N, and O if that makes you feel better. Yeah. Okay. Okay. Now we're done with the distance. That's the idea of the distance. Let's look at the midpoint. Now, the midpoint is exactly what the name suggests. It's the point in the middle between two other points, right? So back to this diagram real quick. You have A and B. If I want to find the midpoint, it would be somewhere around here, maybe, but I'm approximating. So what we're calculating is the coordinates for this area in the middle right here, that point. So this is how you do it. This is your formula. Big pairs of parentheses because the answer is supposed to be a point. Unlike the distance, which gives you a specific answer, right? One value, the midpoint is supposed to give you a coordinates of x and y values, right? Because you're looking for a point. Now again, you have 2 points. One is x1, y1. The other is x2, y2. Now what do? You grab both x values, 1 and x2, add them up, divide them by 2. Take the average, basically. Same here. y1, y2, add them up, divide them by 2. With a comma in the middle. So let's try it. We have 1.8, negative 1.8, and 3, negative 3. Second point is 4.5 and negative 1. Using this formula right here, if I say this is my first point and this is my second point, what do we get? Okay. Over 2, over 2. So my x1 is 1.8, negative, plus 4.5. Now, for the y's, we have negative 3 plus negative 1. That equals. So for the y, you have what? Negative 3 plus negative 1, which is negative 4. Divided by 2 is negative 2. That one's easy. Now let's look at this one. Subtracting 1.8 from 4.5, since this one's negative, so I'm removing it from it, right? So 1 from the 4, that gives you 3. Take an 8 out, that gives you 2.2. Add the 5, that becomes 2.7. So you get 2.7 over 2. Okay. So 7 divided by 2 is 3.5. So, and the 1 divided by 2 is 1, which gives you 1.35. Positive. Now, you don't have to do it in your head like I did. Just calculate it. Use a calculator. And while we're at it, I'm not sure if you guys looked at the syllabus, but for this class, you're not allowed to use a graphing calculator on your exams. You're allowed to use a normal scientific calculator, but not graphing. However, when we get to chapter 4 and we deal with logs, it would be helpful if you have a calculator that can do logs, right? So this is the one I usually recommend. Casio FX991ES, right? Now you can get any calculator that looks like this. I just require to have one feature. You see this button right here? See that? That button. Right? I just need the calculator to have a button similar to this one, where you can enter a log, see this? With a certain base and a certain value. Calculators that can't do this usually have this button, the log button. But if you click this, the base can't be chosen, which means this is a base 10. You only have the log to base 10. And you have the ln right here, which is log base e. You only have those two. So if you don't have a button similar to this one, then you need to buy another calculator. Okay? Now, good news is this thing is not expensive. Like you can get it for 15 bucks on Amazon or something. You find it at Walmart. It's really cheap. It's not 100 and whatever like the TI. Yeah. But anyway, so I just need the calculator that can do log to a different base. So I'm telling you now so that when chapter 4 comes around, you'd have it handy. All right? Okay. What if it says ln log like this? These two buttons? Yeah, those aren't just normal buttons. You'll find those in almost any scientific calculator. This is the one I need. Or I should say the one you'll need. Because technically for those sections, you can solve the questions without this button. It's just I would prefer it if you had it so that on tests you have the option to calculate instead of using just your head, because I know silly mistakes happen and it's like a good security blanket to have. All right? Anywho, so now that we're done with these concepts, let's plot. So we're going to plot functions, okay? Now I'm going to help you identify what functions are and explain them a little bit more in the next section, so that we know what a function actually is. But for now, we're going to just deal with the generic idea just to plot them, to graph it. So we have y equals x squared plus 3. This is what I'm plotting, yeah? Now, in this case, x is considered your independent variable, because whatever x is, nothing affects it, right? So if I change the value of y, it's not going to change the value of x. But changing the value of x does change the value of y. So x is free to be whatever you want it to be, and y depends on whatever x is. So x is your independent, y is your dependent. Now why is that? Because to find y, you need to know what x is. Does that make sense? So I'm going to choose random values for x, plug them in here, solve it, and write down the y answers. Okay? Once you do that, each 2 points or each 2 values is going to give you one ordered pair. Okay, let's start. Now, try to make it easy on yourself, so don't choose like -17 or something like that. Yeah, so choose the simplest numbers possible, but make sure to choose a few positives and a few negatives to establish a pattern. Oh, I think it got stuck. Did it freeze? Oh, there we go. All right, so for example, say 0, 1, 2, 3, and then go -1, -2, and we're out of table, but I'm going to add one more, -3. Okay? So let's plug them in here. If x is 0, then 0 squared is still 0. Plus 3, y is 3. So the answer is 3. Okay. If x is 1, 1 squared is still 1. 1 plus 3 is 4. So the answer is 4. Okay. If x is 2, 2 squared is 4. 4 plus 3 is 7. Now, oops. 3 squared is 9. Plus 3 gives you 12. All right. Now, what's going to happen to the value if x is negative? Since I'm squaring it, nothing. It's going to give you the exact same result. So C. -1 squared is +1. Plus 3 is 4. See those? -2 squared is +4. Plus 3 gives you 7. And -3 squared is 9. Plus 3 is +12. So now let's write down the pairs. Parentheses, comma. 0 goes here, 3 goes here. 1, 4. 2, 7. 3, 12. -1 and 4. -2 and 7. -3 and +12. These are my points. Next step would be to plot those points. So here we go. Let's start with this one. X is 0, y is 3. So x is 0, y is 3. So the point's right here. Okay. X is 1, y is 4. And then x is 2, y is 7. So let me count 7. This is 4, right? 5, 6, 7, 1, 2. Point is right here. And x is 3, y is 12. 12 is all the way up here. We have it marked. So I'm just going to go horizontally by 1, 2, 3 to x3. And this is my point. Yeah? Now let's do the other half. Now, since y is still 4 for x -1, that means the point's going to be right here. Just mirror at -1, 4. And then you have -2 and 7. So the point is going to be right here. And then you have -3 and +12. So this right here. So it looks like a bowl. This is the graph of a quadratic equation, or in this case, function. Yes? Now, I've been asked before, when do we say equation and when do we say function? Well, the hint is, in order for it to be an equation, you have to have an equal sign with a number that follows. Over here, you have an equal sign, but on the other side, we have a what? We have a y. Yeah? You don't have a number, which makes this a function, not an equation. Right? So you don't say equation, you say function. But even then, functions have requirements. So well, I'm teaching them to you in the next section. Anyway, now let's connect the dot. Now I'm sorry about my drawing because I'm bad at this. I always get teased by my students about this. It's like, you're a math teacher and you can't graph. It's like, yep, I'm a math teacher and I can't graph. Or I can't graph pretty, at least. And that's like that. Any questions so far? Okay, good. This is one of the fun sections. It's super easy. Everybody has this down? Okay. Let's move on. Alrighty. Now, for the next of the, actually there's something I want to go over, so maybe I won't graph everything, but just enough to give you the idea. Okay. How about this one? Let's do these two, because they're both fun. This is the radical, and this is an absolute value. So let's do that. Here we go. Root of x plus 3 and y. So, okay. And again, x is the independent and y is the dependent. How can you tell? The dependent one is going to be written alone on one side of the equality, and the independent is going to be on the other side with other things applied to it, like root and plus 3 and everything. Yeah? So when you have y equals and the x with a bunch of stuff, that means y is the dependent one, because it depends on what x is. You're calculating it. Make sense? So that makes this the dependent one. So we choose the values for x, and then we plug them in. Okay? So let's think about that. Now, we'll see. I'm going to go with -3, -2, -1, and then 0, 1, 2. All right? We'll plug in those in here, and finding the answer. Now, you're free to choose any other values you want, but these are the easiest to plot since the simplest. Just keep in mind that whenever using an x value to plot in a radical function like this one, make sure to choose values that don't turn the inside of the root to negative, right? So don't choose a negative number bigger than 3. In that case, for example, -4, it would be -4 plus 3, which is -1, and you're going to end up with a negative underneath the root. Does that make sense? So avoid that. So now let's plug those in here and see what happens. So -3 plus 3 gives you 0. Root of 0 is 0. -2 plus 3 gives you +1. And square root of 1 is 1. -1 plus 3 gives you 2. So it's the root of 2. Okay. Now 0 plus 3 is 3. So it's going to be the root of 3. 1 plus 3 is 4. So it's going to be square root of 4, which is 2. 2 plus 3 is 5. So it's going to give you root of 5. Okay. Now, so what are my points? We have -3 and 0. -2 and 1. Now I'm going to approximate -1, and what's the root of 2? It's about 1.4. Yeah? Okay, and then we have 0 and root of 3. What's root of 3? 1.7-ish. This one is 1 and 2. And then 2 and root of 5, which is about 2.2-ish. You can use your calculator to find them. It would be easy if you did this before you stop plotting, because then you know what to look for. Okay? Now, let's look here. So we have what? -3 along the x, so 1, 2, 3, and 0 for y, so the point is right here. Okay? -2 for the x and +1 for the y, which is right here. And then -1 for the x and 1.4 for the y. So that's 1. I'm going to go a bit almost to the half point and draw it right here. Okay. And now 0 for x and 1.7. 0, 1.7, a little bit more above, but not quite at 2. See that? Okay. And then at 1, this one does go to 2, exactly at 2. Are you noticing a pattern? It's going up slowly, and the rate it's increasing at is diminishing, like it's growing slower, right? And finally, at 2, it's 2.2. It should be right around here. So the graph is doing this, but it's growing slowly, like that. There's a curve to it, slightly. Yeah? This is the graph of a radical. Now let's look at the graph of an absolute value function. In this one, if you notice, I did what? I switched, right? We have x equals absolute value of y minus 4. So what I'm going to need to do is think of y as my what? My independent variable, in this case. And x is my dependent, since x is the one on one side all by itself. Okay? Which makes x the dependent one, and y the independent one. So the independent one is the one you pick any number you can or you want for it. And you plug it in to find the other one. Okay? So we pick for y instead of x this time. I wrote picky. All right. Now, We start at the y. Okay, so what numbers am I choosing? Now look here. We have an absolute value, which means if you choose positive or negative, it won't matter, right? So I'll just stick with positive. So we have what? 1, 2, 3, 4, 5, and 6. Make it easy. Now I'm plugging in here to find the answer. Yeah? 1 minus 4 is what? Negative 3. Inside the absolute value. Okay? 2 minus 4 is negative 2. Inside the absolute value. 3 minus 4 is negative 1. Inside the absolute value bars. 4 minus 4 is 0. So I'm just going to write that as 0. You can add the absolute value bars if you want. Doesn't change it. Now, 5 minus 4 is 1 inside the absolute value bars. That looks like 101 and 11, sorry. But yeah. And 6 minus 4 is 2 inside the absolute value bars. So, okay. Now let's write the pairs, starting with the x. Okay, so a negative number inside the absolute value turns what? Positive, right? We don't care about the sign. So if I'm going to remove this, this turns into 3. And y is 1, so it's 3, 1. Negative 2 becomes positive 2. And then you write the other 2. Negative 1, get rid of the sign, and then the 3. 0 is still 0. Positive 1, still positive 1 with the 5. And 2 is still 2 with the 6. These are your points. Now, let's plot. X at 3, so you have 1, 2, 3, right here. And y at 1, so you go up 1. This is the point. Next, we have 2 and 2. So x at 2, y at 2. Okay. Next, we have 1 and 3. So x is 1, y is 3. Go up here. And then 0 for x and 4 for the y. So it's right here. After that, we have 1 again, but at 5. So it goes up there. And then 2 and 6, which is right here. And do you see the pattern? If I draw lines like this, the graph is doing that, right? Now here's something interesting. That's why I chose to flip them in this example. It's because when the independent variable, let me go down a little bit. When the independent variable is x, the graph is focused around the x-axis, right? So the pattern appears to be along the x-axis. Now, notice here that when I flipped it, it's kind of focused around the y. Like if I flip it, this is what the absolute value function is supposed to look like. Yeah? But we graphed it sideways. Why? Because I made y my independent variable. Does that make sense? So this is what it usually looks like. Like if we graphed it to x instead of y, it would look like this. But because we did it to y, it was what? Sideways. Y was the center. Yeah? Just something interesting I want you guys to see. You're not going to see these cases often, though. I'm not going to give you a function where x equals something in terms of y. And you'll see why in the next section. Okay? I don't want to complicate things too much in this one. Just learn how to graph. Okay? So I'm going to move on to the next example. Oops, dropped it. Okay, now let's look over here. I want to introduce you guys to the idea of the intercepts, x and y intercepts. Now, these points are the points where the function, or I should say, the graph, touches the x or y axis, okay? So, looking at the circle right here, I want you to tell me what the x-intercept is and what the y-intercept is. So to find the x-intercept, you have to look along the x-axis. Where does the circle touch the x-axis? Right here. Yeah? Which is what? The point of 1, 2, 3. Okay. So the answer is 3. Is that right? Yeah? Well, you're missing something. You're missing something. Can you tell me what it is? Whenever I ask you for an x or y intercept, I'm asking you for a point. So if you're going to express a point, how would this look like? So this is the point I'm talking about right here, which is what? 3 for x, that's true. But what is it for y? It's at 0 vertically. It's not going up. Therefore, it's the point 3, 0. Yes. So whenever I'm asking you to give me an intercept, you're going to give it to me in the form of a point. If you give me the number, you did it wrong. You lose points for that. And if the question is multiple choice, then you lose the question completely, which is a shame. So make sure to know that it's supposed to be an ordered pair, a coordinate. Yeah. Now, one thing that you need to notice always, if I'm asking for the x-intercept, the x is the only one that's going to have a value. The y is always going to be 0. Same happens for the y. If I'm asking for the y-intercept, you're going to have a number for the y and a 0 for the x, because otherwise it won't make sense. I'm asking you for a point that's touching the axis, which means that the other axis didn't move at all. Make sense? Which is why they're always going to be at 0. So what is the y-intercept for this one? 1, 2, 3, which makes sense. It's a circle. So let the value of y equals 3. So don't give me the answer like this. Give it to me like that. 0, 3. So x didn't move. We're still at 0. And you go 1, 2, 3. So it's 0, 3. Okay. What about this one? So we have 1, 2. This is 0.2. And 1, 2. This is negative 2. Negative 2 and 2. Okay. So, oh, and when you go down, you have 1, 2, 3, 4. This is negative 4. I just wanted to make the values clear for you. So can you guys give me the answers? What are my intercepts for x? Yes. Negative 2 and 0 for the y because it didn't move. And then positive 2 and 0. You're right. So negative 2 and 0. Positive 2 and 0. Awesome. Okay. What's the y one? Ooh, close. Flip it. Because the x value has, there you go. The x value is going to be 0, and the y value is going to be the negative 4. That's right. So it's 0, negative 4 for this one. Yeah, remember, first one is x, second one is y, always. So since y is the negative 4, it's going to be the second one. Any questions so far? So far, so good? So we got how to plot points. We know how to find the intercepts. You got how to do the distance and midpoint calculations, right? And we plotted a few functions. Now I'm going to show you how to find the intercept by calculating instead of a graph, because I'm not always going to give you the graph. So let's look at this one, for example. What are the x and y intercepts of this equation right here? Okay. So if you look at it, you have x and y in here. All right. Now, based on the concept we just said, in order for a point to be considered an intercept, right, one of the two values, x or y, has to be 0, right? Otherwise, it wouldn't be touching the other axis. So if I want to find the x-intercept for this one, that means y has to be 0. Yeah? So you just set it to be 0. You assume it's 0. Otherwise, the point you're going to find is going to be an intercept. Does that make sense? So in order for it to be the x-intercept, y has to be 0. And we solve on that based on that. So you grab this, which is y minus x squared, and it equals 9. And you set it to be equal to 0 minus x squared equals 9. Which basically means that x squared is negative and equals 9. So if you turn this positive, x squared equals negative 9. Now that's a problem, right? You can't solve this, at least not without issues. So there is no real solution. Which means this one what? Has no x-intercepts. So no x-intercept. So, all right. What about the y? Intercept. I'm going to set x to be 0. Right? So when you're finding x-intercept, y is 0. When you find the y-intercept, x is 0. The opposite is going to be 0. Okay. So again, same equation, which is y minus 0 squared, which is still 0, and it equals 9, right? Which means y is 9. So we do have a y-intercept for this one. It's 9. But when you give me the final answer, please write it like this. Okay? That's your y-intercept. Okay, let's do the next one. I'm going to leave the top one visible so you can see both. Okay, so for this one, let's try and find the x-intercept. So if I'm finding the x-intercept, y is what? 0. Okay. So I'm plugging in 0 for y. So we have x equals absolute value 0 minus 3 plus 2. Right? So 0 minus 3 is still negative 3. Take it out of the absolute value and it becomes positive. So you have positive 3 plus 2, which is 5, right? So the answer is 5. That means the point is 5, 0. Okay. What about the y-intercept? I'm setting x 0. Now let's solve. Okay, so we have 0 equals absolute value of y minus 3 plus 2. Okay, so when we said you want to solve an absolute value equation, first thing you need to do is what? Move everything from the side of the absolute value to the opposite, right? Isolate the absolute value before you start solving. So I'm grabbing the positive 2 and moving it here. Turns negative. So you have y minus 3 inside the absolute value, and it equals negative 2. Now that's a problem, right? We said that the absolute value that cannot equal a negative number. Therefore, there's no solution for this one. And since there's no solution, that means there is no what? Y-intercept. Okay? Because that's what you're originally trying to find. Make sense? Any questions, you guys? All good? All right, that's it. Hope you guys enjoy the rest of your morning. And for those who couldn't access the homework, Haley and Rudy, please let me know how it turns out, what happens after you contact the customer support. The link is in the chat way above before we start lecture. And let me take roll before you leave. I don't think anyone did yet. Oops. Here you go. All right, we're good. You can go now. And I'll see you on Thursday. Stop sharing that.